Hello and welcome to this SUSECon digital session on SAP automation. I'm Steve Stringer. I work in the SAP Emerging Technologies team here at SUSE, and I work mostly in automation. And I'm going to be giving you a brief tour today of the automation we have available for SAP. If we have a quick look at our agenda today, we'll be looking at why to use automation for SAP. We'll be looking at our available technologies, which are Salt and Ansible. We'll do a quick feature comparison of those two technologies. We'll dig into what an Ansible role is and the way that we've designed our Ansible roles for SAP. And then we'll go to a quick recap at the end. But before we start all that, we need to start our demo. If you just excuse me while I change screens, you can see here that I'm logged into two remote nodes in the cloud. They are AT HANA 01 and AT HANA 02. As you can see, they've just been provisioned. There's very little happening on the systems themselves. There's no repositories defined. You can see that I've got some disks available but not used. There's only root and some pseudo file systems mounted, and boot EFI. The HANA systems are going to be installed under the SU1 ADM user. If I do top minus SU1 ADM, you can see that user doesn't exist yet. So there's absolutely nothing configured on these systems. They're freshly provisioned. So what I'm going to do is I'm going to run my Ansible roles against them that I've packaged up in a script. And you can see that hopefully they're going to start off very shortly. Always the fun bit. And there we go. The first task that you can see running by is it's going to create some SSH keys and distribute them between the hosts. And we're going to come back and look at our progress at the end of the session. So why do we think you should be using automation for SAP systems? Typically, a business running something like ERP or BW, they may refresh those systems every 3, 5, 6, 7 years, depending on the underlying technology. When we think about automation, especially with infrastructure, we are sometimes thinking about large web dev environments, things based on Kubernetes maybe, where things are based out of a CI pipeline and getting rebuilt on an ongoing rolling basis. And that's really a good reason to use automation. So if SAP isn't being deployed anywhere near as often, why do we still think it's important? There's three key factors, really. Number one is consistency. It's really important when you install SAP systems that they're consistent amongst themselves. So when you install SAP, you will always typically install 3 tiers. So you'll have 3 environments. You'll have dev, QA, and production at a minimum. You may have pre-prod as well. You may have dual track development. And it's really important that those systems get configured exactly the same way, because you transport code through those systems and elevate it into production where it goes live. Now, if you've got something like if you're installing from a checklist or a set of instructions, it's really easy as humans to miss steps off or do things wrong. Now, if you've got a obscure kernel parameter that needs to be set everywhere, but it's only been done in dev and QA properly, when you get into production, your code might not actually work as efficiently or properly, and you won't know why. So consistency is really important when deploying these solutions. Also, repeatability. So what I mean by repeatability is to be able to run the same set of automation over and over again over different time frames, and that still be consistent. So in the cloud, where you want to keep costs low, at the beginning of a project, you might only deploy your development systems. Your QA systems may come down the line 3 months later, and your prod systems may come down the line another 3 months later. So it's really important to get the automation right, that no matter if it's 6 months later between dev and prod being deployed, the results are still consistent and the same. So we've got consistency and repeatability as kind of two different things. One of the other things, a big advantage that you get with automation is speed. Obviously, for a computer to do a bunch of tasks in series, it doesn't need to read the next instruction, it doesn't need to wait, it can just perform those tasks straight away after each other. It doesn't need lunch breaks and things like that. So speed is a big thing that you get, but really that's a side benefit of consistency and repeatability, really. Speed is great, but those first two are really key. So let's talk about the automation technologies that we have here at SUSE. We use SALT, and to give you a quick overview, SALT is written in Python, which you'll see is a bit of a theme. It uses the client-server model, so we have software that sits on the SALT controller, the SALT master, but we also need to deploy SALT minion, SALT client software, on all of the nodes. And that client-server model means that we get an always-on, very fast communication between the master and the minions. So that's really good for when you are using thousands of machines. You can get responses almost straight away. But salt is quite compartmentalized. There's lots and lots of different bits to it. You've got salt grains, salt pillars, salt states, salt reactors. There's a lot going on. And that can really mean that you've got a bit of a steeper learning curve there. And that can put some people off, but some people really like it. Ansible, on the other hand, again, like I said, there's a theme. It's also written in Python. But it's agentless, so it uses SSH for connections. So unlike the client-server model, it's not always on. When you want to do something new with Ansible, you need to create a new connection. And you have to go through authentication and everything like that. So it is a little bit slower. But Ansible is somewhat simpler in the way that it's architected. So there's only really two things that you need to learn, which are playbooks and roles. Everything else, everything that you want to do can fit in one or two of those things. So let's talk about where we are with our technology stacks with SAP automation. Well, we've had Salt automation for SAP for a long time, and the packages are in the SLES repositories and they're fully supported. And with the Salt automation, we can do things like install HANA, NetWeaver, cluster them, S4 as well. So there's a whole stack of things that we can do. And we can automate some of the technologies around it for NFS, for DRDB, etc. Because it's Salt, it integrates with SUSE Manager, so you can use SUSE Manager to push these states out and configure SUSE Manager client systems to HANA, NetWeaver, and S4 installs. And there's also a project to provide end-to-end automation for Salt with Terraform as well. So you can go from a completely unconfigured cloud to having HANA clusters running S4 up in next to no time. Ansible, on the other hand, is a new technology to SUSE. It's something that we've been working on for a few months. We're planning for new Ansible roles, the ones that we're previewing today, to be available in SLES 15 SP5 as a technology preview. So it won't be fully supported from day one. Again, we're sort of targeting the same sort of things, the installation and clustering of HANA, NetWeaver, and S4, and other bits of technology you need in order to do that. And we also are planning SUSE Manager integration. And again, some point in the future, we'll have a project where you can download a container and run end-to-end automation on the three major clouds and KVM. So a little bit about our SALT states and formulas. There's a number of repositories that you can find out there on GitHub, which are also in our SUSE product repositories, SLES for SAP. And you can follow this link to find the end-to-end automation using Terraform. And there's also a link there to a previous SUSECon presentation on the SALT states as well. But really, because Ansible's new, we're going to focus a little bit of time on that today. So when we talk about Ansible, we are generally talking about Ansible roles. Ansible roles are what we are designing and producing to run SAP systems with. So an Ansible role is really a collection of tasks, variables, handlers, all the other bits that Ansible uses in order to perform a specific set of tasks to perform a desired state, if you like. So you may be familiar with Ansible playbooks. When Ansible playbooks get very big, they become unwieldy. So if you want reusable code, that's why roles were designed. You can package your uh, code up in a role, and it makes it more reusable, as we say. Uh, so roles can often be uploaded to the Ansible Galaxy, where they can be downloaded, and they can with the Ansible Galaxy command. So if you've got Ansible installed on your system, you can type Ansible Galaxy and install roles really easily that way. But of course, like all code out there, the quality does vary. So when you're using Ansible Galaxy to download roles, just be wary of that the quality may vary. Always look at the reviews, have a look at the code yourself, and be sure that you're happy with what you're using. So Slides for SAP roles, what are we trying to do? Really, our goal is to create a set of reusable, robust, user-friendly roles that help customers configure their SAP solutions on SLES. There's a bunch of roles that are currently in the making, all kinds of different things to prepare SSH keys, install and configure SAPtune, do storage for SAP, install HANA, back it up, do all the system replication. We support SWPM for installing S4, and we've got a clustering role where we can cluster solutions as well. But really, what we wanted to do, as I said in a couple of slides ago, was provide customers with really high quality roles. And sometimes when you download roles from Ansible Galaxy, you do find problems. And these problems come in one of two different ways. Firstly, there's problems with inputs. And what I mean by that is when you run an Ansible role, you need to give it input. You just like running any bit of software, you need to instruct it how you want it to work and what you want it to do. So for example, let's think about installing HANA from a role. You need to give it bits of information like what SID you're going to use, what instance number you're going to use, and where the binaries are, where's SAPcar, where's the HANA installations are. Now, what can happen sometimes is the inputs are not correctly validated, and you can get halfway through a role when a problem is found. And then running the role without the correct inputs can sometimes lead to systems being left in a sort of semi-configured state, neither one thing nor the other. So that's something that we really wanted to address when we wrote our own roles. Outcomes as well. Sometimes a role can think it's done what it's supposed to have done, but it hasn't really checked it well enough. Sometimes it relies on a return code of 0 from a module, and then it just assumes that, yes, I've done my job and everything's worked perfectly. And that's not always the case. And again, that's something we wanted to address in our roles. So we've got a very specific design pattern for our Ansible roles, and the main entry point to an Ansible role is the main.yaml file in the tasks directory, and every one of our roles has the same file. It looks like this. We do three things. We run our pre-checks, so we've always got a dedicated pre-checks.yaml file. Then after they've passed and have completed successfully, we run our tasks, which are in a tasks.yaml file. And after those things have run, tasks actually do the work, we run our post checks in our post checks YAML file. And post checks, well, I'll describe all of these later. Okay, let's go through them one at a time then. So let's start with pre-checks. What do pre-checks do? Basically, our pre-checks, they validate input. So again, the example I had earlier, when talking about installing HANA, there's a whole bunch of inputs that we need. We need the user to tell us what the SID is, what the instance number is, where the software is, HANA master passwords, things like that. So in the instance of a SID, first off, we check it's defined. What we also do is we check it's the right number of characters. Is it 3 characters? Are those 3 characters compatible with a SAP SID? The first one needs to be an alphabetical character only. The second 2 can be alphabetical or numbers. So we check the structure, we regex it. We also check that it's an allowed SID. Some of the things you're not allowed to use, things that look like SQL keywords, for example, aren't allowed. You're not allowed to have IBM. You're not allowed to have SAP as a SID. So we do lots and lots of pre-checks to make sure everything that the customer has supplied us will work later on down the line. We also check the environment. So for example, again, if you're installing HANA, we check the environment to see if, say, libatomic is installed. And if it's not, we tell the user that they need to install certain things before running the roles. What we've decided is that our role shouldn't be in charge of package management. The user needs to do that externally or with a tool like SUSE Manager. Now, if any of our pre-checks fail, we print the customer a really useful error message to show what has failed and why. And I'll show you an example of a pre-check here. This pre-check is in Ansible. It uses the assert tool, the assert module, which most of our pre-checks do. And this is all about the HANA master password. So we look at the HANA master password, we check that it's 8 characters or longer, that it meets the complexity requirements, that it's got a lowercase character, an uppercase character, and a number. And of course, if that fails, we print a easy error message for the customer to understand. So it says the value of the variable HANA master password does not meet blah, blah, blah. And it goes on, it really clearly tells the customer what went wrong. And what's really important here is as soon as this assert fails, execution stops. So nothing gets configured. We don't get halfway through configuring HANA before we do this. We check everything up front and we don't execute a single thing. The customer gets a friendly error message and they know exactly what to do to fix the problem. And that's really important. We don't want to get halfway into the HANA installation before we get a failure. We want to capture it up front to make sure everything's okay. Okay, so that's pre-checks. Talking about our tasks now. We've got some guidelines on the tasks that we always follow. We use Ansible modules whenever possible. So Ansible modules are the building blocks of Ansible playbooks, Ansible roles. If there's modules to do all sorts of things like place lines into files, add users, add packages, etc. We'll always use an Ansible module if we can do a particular task with an Ansible module. When you can't do a task with an Ansible module, there are 2 special modules called shell and command, which allow you to do stuff on the command line as if you were typing a command. But we only use these modules whenever it is absolutely necessary. We never use the shell for text processing. So if there's a bit of information that we need from a file or from the output of a command, we'll always bring the content of that file or the output of that command back into Ansible for processing. We don't use sed, awk, head, tail, grep, anything like that on the command line of a remote system, because we're just setting ourselves up to being reliant on certain versions of sed, awk, and stuff working in different ways. So we bring everything back into Ansible for processing. We always ensure that our roles work with check mode. So when you run a Ansible playbook or an Ansible role in check mode, it should show you what changes without actually changing anything. And we always ensure that that works correctly, because that's really important for checking that what will change if you run the role in a normal mode, but also making sure you can run roles in check mode afterwards to make sure that the configuration hasn't varied from what the role originally configured. And we ensure that we remain idempotent, which is absolutely key, really. Ansible, like most automation, should support idempotency, which means that Ansible will only ever change anything if the state of the system is not what's desired. So if we run a role and it completes successfully, we should be able to rerun that role and see no changes being made to the system. And we do a lot of checking around all of these things to make sure our roles behave and are as nice as possible. Okay, so quickly moving on to post checks. Post checks are really sanity checks, things that we do after the modules have done their tasks to ensure that we know exactly what's happened and to ensure that the states that we want have been reached. And the best way to show this really is with an example. So this shows us an example of a post check that we do with the SUSE registration role. And this really is a really simple one. When you run SUSE register or register cloud guest, sorry, SUSE Connect or register cloud guest, we'll be able to run the command SUSE Connect -s, which will give us a JSON summary of the current registration status. Now, what this command does is it looks at that summary and it checks that the system is actually registered. So the task goes through, it registers the system, but we've just got this sort of belt and braces post check where we can ensure that the system thinks that it's registered. And you can see it's got a straightforward error message, fail message for the customer to say that registration appears to have been unsuccessful and that they need to check a few things. Also, as I mentioned before, uh, we're very careful about when we do stuff, and we do not run this check in check mode. So the reason for that is a customer may run the registration in check mode to see if anything needs to change on the system. But unless the system is registered already, this post check will always fail. So if they haven't registered the system, they run it in check mode, we skip this step because we know that it will fail because the system's not registered. Okay, that's a really, really brief overview of the new Ansible roles. And now we should hopefully be able to review the demo. So we can see that we've completed it basically. All the tasks that we asked it to do have now been done. And if we log back onto our system, if we do a quick check first, DF, we can see that we've now got a USR and a HANA file system. If we do top U SU1 ADM, nope, sorry, SU1 ADM, we can see that we've got various processes running under this user. We can see we've got the HANA name server and index server. So that certainly looks like HANA's up. And if we do CRM status, we can see that actually we've got a HANA cluster. It's running on GCP, so we've got some Stonith devices there. We've got a virtual IP address. We've got SOCAT running for the load balancer. We've got the whole HANA clone sets going on as well. So we've been able to, I mean, that was running for less than 20 minutes. We're able to, with these roles, completely configure systems up to the point that they're running a HANA cluster. We can also reach further and we can install NetWeaver or S4 as well. The cluster inside of that is still currently in development. But yeah, and if we go onto our second system in the cluster, we can run the same stuff, CRM status, and we can see the other side of the cluster as well, and it reports as the first side does. So hopefully we can all agree that that worked very nicely for us today. Okay, so a little bit more on the Ansible roles. The code is hosted in the SAP Linux lab. You can see clearly there where the link is. We would love you to come along, have a look at that code, try it out for us, test it, raise any issues that you find, put in any feature requests. We would love to hear from you, and we would love you to join us on that. So finally, just a quick recap. So even if you deploy HANA infrequently, automation is still important because it gives us that consistency and that repeatability. We can get rid of a lot of our deployment issues by using automation. Again, we don't currently, well, most customers don't frequently deploy their SAP systems today. The way that I see SAP changing over the years, over the next coming years, I think people will be deploying SAP more and more as they move from on-prem to cloud, as they modernize their systems. The more continuous deployment of SAP is coming. I'm sure SAP will start to be deployed in containers at some point in the future. So getting on board with automation today is really, really key for SAP success in the future. As SUSE, we have SAP automation based on Salt and Ansible that we've discussed. And we've also discussed the role design and done a demo of our new Ansible roles. And that really concludes our presentation for today. I hope you've enjoyed it. And again, thank you for watching, and I hope to see you again very soon. Many thanks. Bye bye.